Okay, let's take a look at the PE2. Alright, let me just move this here like this so we can see the PDF. Okay, I'll just quickly skip this question. Okay, you can read it at your own time and we just go through question 8. Okay, so we model the process with only one row. Alright, so this picture shows that this, okay, basically it's a vector, right? 0, 1, 2, 3, 4, 5 is the number of elements in the vector, and these are the values, okay, in the vector. So if we were to choose the pit number indicates which pit we are taking the seeds from. Alright, so we take the seeds from here, basically make this 0, and then we go down +1, +1, okay, to all the rows. Okay, so basically what we need to do here, first thing we need to do is get the seeds on hand, right? Seeds equals to row pit. Alright, so in this case, pit 1, we need to get 4 seeds, right? So seeds 4. Then next thing we need to do, row pit now becomes 0. Okay, no more seeds in the pit. Okay, we also need a store, or rather, let's just handle the sowing process. Okay, so while we have seeds, while seeds more than 0, we have seeds in hand. We go to the pit. Okay, on the left, smaller pit, and we drop the seeds in the pit. Alright, so row pit. Now we need to handle this case, right? So if we are at pit 0, okay, if we are at pit 1, we go back to pit 0, okay, we drop a seed in, so this becomes 5. Now if we are at pit 0, we go back, it becomes -1, right? So -1 is beyond the vector. So -1, we need to add the pit to our store. Sorry, add the seed to our store. Okay, so we need to have we cannot just add 1 to the pit. We need to check if pit is less than 0, then we need to add 1 to our store. Okay, so which means here I need a new variable store equals 0. After we add 1 to our store, we need to make it such that we need to move our pit to here. Means our pit has to become 6. Right, so the next round, the pit -1 will bring us into this, right? We need to wrap around. So to get our pit there, you realize this 6 is 1, 2, 3, 4, 5, 6. It's actually the size of the vector. Right, so pit equals to row dot, okay, row dot length. Else if it's not, okay, so since we drop 1 seed, right, seed minus equal 1. Then once we are done with all the seeds, the function requests us to return how many seeds we drop into the store. Okay, so here the row will be updated, okay, because we passed by reference. So and our row is correctly updated. Okay, so question A is done. If you run this, oh, seed not oh, sorry, I think this is size. Yeah, seed was not declared in, okay, it was seeds. Okay, right, so let's see here. Yeah, Okay, did we get the correct thing? Yes, so the answer is correct. Okay, part B. Now, part B. Okay, so why we have part A, B, and C, right? So actually, initially we have part A and we have part C. Then I thought uh, maybe part A might be too hard for some. So we introduced part B, which is actually the easiest part to do. Right, basically what you do is, this is a vector, this is a slice. If you are slicing 2 to 5, means 0, 1, 2, we start at 2, and 3, 4, 5, we end before 5. Alright, so this is a simple case of doing this. So here we create a new vector, vector v. Okay, create a new vector for integer I equals start at start, while start less than n, while I less than n, I plus plus. So this is your typical for loop. Okay, this is basically something which we covered before midterm, right? For loop. So if you do this, then what we want is we want to copy, or rather v dot push back. Okay, what do we push back? Oh sorry, here already have v. Okay, we cannot change v here. Let's call it w then. W. Okay, so w push back vi, right? Okay, here basically then just return w. Alright, so to check here, if I equals to 2, 2, 3, and 4, when I becomes 5, it stops, right? So not excluding. Okay, so this part here will exclude the end. Okay, so we'll basically, if you start from 0, will it include 0? Yes, it will include 0 all the way till this is index 5, 6. Okay, then it will also include. Okay, so this will work. Alright. So if we run this, okay, so this is what we get. Okay, so now part C. Now part C is where things get a little bit interesting. Actually, you don't need to have done. Actually, all these parts are independent. Okay, you can solve part C without solving A or B correctly, right? Just like as you can solve part B without solving C correctly. Okay, so the idea of part C, okay, so part C requires a interesting look. Okay, so what happens is this: you notice we are sewing this way, right? Down, down, and go up, across, and come. So what we do is you take this entire vector. Oh, sorry, my drawing is not very good. Okay, we take this entire vector, concatenate here, put it here. Okay, so we have 0, 1, 2, 3, 4, 5, 5. We just put it here. Alright, this is a hint because we said that where's the hint? We have this function concat that's been defined for us. Okay, so we put this function here, then we can use our also function. Right, the also function does not care how long it is. So we put this here, it's as though it's like one continuous row, which is correct, right? As long as it comes to the store, it wraps around to number 5, which is here at the end here. And it continues sewing, and then this will give us the correct vectors. After that, we split the vector up, right? We slice the vector up. We use part B, okay, to get what we want. Alright, so let's get on to the answer. So I will create a new vector, row equals to concat, but I concatenate our row with their row. Right, so we get this long vector. Then my store is just, I call sew function using this row and pit. Okay, so the sew function from part A will do the sewing for me. End of the sewing, what I get is this, right? I will get this. This is the result of the sewing. I'll get it with this part here, right down here. Okay, so this will be 0, 1, 2. I mean, this is the index. Then I need to slice it out now. Okay, to slice it up, I must figure out how much to slice, right? Well, I can take length divided by 2 if I want to. All right, so I can slice length divided by 2. Okay, in my model answer, I save the size first before I concatenate, but it doesn't really matter. Okay, you divide by 2, you still get the same thing. Okay, so our row equals to slice row from start to row the size divided by 2. Is that correct? Okay, I don't think it's correct, but let's check it out. Okay, so here our size is 6. Here is 6, right? So our size is 12. 12 divided by 2 is 6. 0, 1, 2, 3, 4, 5. Right, actually works. Okay, so correct. Okay, 0 by divided by 2 works. Okay, then we update their row. Slice from row size divided by 2 all the way to row size. Okay, so this one will slice from 6 to 12. So this is 6 all the way. The last one will be 11. Okay, so 6 to 12 is the correct slice to put. So this will work. Okay, then after that we just return store. Right, with the int store here. Okay, why didn't this int become blue? Okay, maybe the color doesn't change. Okay, this looks correct. So let's run this. Okay, take a look at our test. So we get 5550455, correct? This is 457198. Yes, correct. Okay, so this part here might be a bit misleading. Why we get 457? You must remember it is in the perspective of the other person, right? So if you are clearing this, so we will put 1 in the store. Then we come down this way, right? Come down this way. Is because the biggest number first, right? Biggest number first. So come down this way. So it will be okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's correct. 457198, which is what you get here. Okay, so that's all for P2. Right, that's the solution for P2. Okay, of course you will take some time reading, understanding, and then figuring out this trick. But once you figure out implementation, it's not that hard. Okay, so all the best for your finals. Hope you did well for your PE2.